Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit Oscillations. So let's begin with today's class. In today's class, first we will discuss about the time period. Let's have a look. How do we calculate the time period? We can say time period is it is the time taken by the particle performing SHM to complete one oscillation is known as the period or time period of an SHM. It's a simple harmonic motion. So how do I find out the time period? Let's see the expression for the time period of an SHM. Let's suppose I have the relation which is x is equals to a sine omega t plus alpha, and if I rearrange it, it is x is equals to x dash is equals to a sine omega into bracket t plus 2 pi by omega plus alpha, or it would be an x is equals to a sine omega t plus 2 pi plus alpha. This is equals to x when I say it's a 2 pi plus alpha. When I say it's a 2 pi plus alpha, that means if it's a sine of 2 pi plus theta, that is always the sine theta. Yes, this is the trigonometric functions. So this is a sine omega t plus alpha, which means x dash and x are both are the same way. That means it is the time period of an SHM, which is equals to t is equals to 2 pi by omega, or or this means that the particle is at the same position. It is going to repeat itself after the time period of 2 pi by omega. Now let's take a case of the spring and block system, that we know that the time period of the spring and block system is t is equals to 2 pi root of m by k, where omega square was equals to k by m, and that is the k was the force per unit displacement divided by m is the mass. So you can write it's an omega square is equals to a by x as well. From this, it's a omega is equals to root of a by x, and that is what x dash is equals to x. So what I understand is the omega, basically it is the under root of acceleration per unit displacement, or I should say it's in t is equals to 2 pi by omega. So the time period is equals to 2 pi divided by under root of acceleration per unit displacement. From this, it's an omega is equals to root of a by x. Let's check out the frequency of an SHM. Basically, frequency is the number of oscillations. It's a number of oscillations completed per unit time by a particle performing SHM is known as the frequency of an SHM. It's an f is equals to 1 by t, or I should say it's an omega by 2 pi, and this is equals to 1 by 2 pi under root of k by m. This is the frequency of the spring and block system. SI unit, it's in hertz, and dimensions for the same, it is the m0 l0 t minus 1. I hope this is clear. So this all are the theoretical aspects. Let's have certain practical aspects of the time period and SHM. Let's suppose this is the x and this is the t, and we have a sine function something like this. When I have been asked to complete a one time period, what it mean? Let's understood that this is the mean position. So from the mean position, this is x equals to 0. You have reached to the maximum. Again, from maximum in one direction, this is what we call as an amplitude. Now you know this. From the maximum, again you reach to the mean position. From this mean position, again you reach to the maximum, but on the other side, or it would be in the negative one. It's a minus of a. Again from this position you reach to the minimum. So if you have completed this much motion, then that is to be considered as a one time period. I hope this is clear. So if you take a case of a simple pendulum, to understand this, that let's suppose this is the mean position of a simple pendulum, and this is performing an SHM. If this is performing an SHM, it will go up to this, let's say and on this side, let's say it will go on to this. So from this mean position, it reaches the maximum position. This is probably the first motion. From this position, it will again reach back to the mean position, but it is not going to stop here. It is again going to move in this direction. This is the third step, and it will come back to the mean position. So if you have completed this four steps, first, second, third, fourth, then time required to complete this four steps will be considered as a time period. I hope now you understand what I mean, what time period is. Or I should say, let's say this is first, from mean position, mean to maximum position, maximum to again mean position to maximum, but in opposite direction, and from that direction to again mean position. If you have completed this, this is what SHM is. I hope this is clear. But every time you cannot go for the 0 0 to mean, mean to 0 0 to again mean, and mean to 0. Yes, this is simply not possible. Or it may be time taking process. So what we can assume is that time period, it is the time when you complete your four quarters. Now what I mean by quarter is, let's have a look, that this is the first quarter, this is the second quarter, this is the third quarter, and this is the fourth quarter. I hope this is clear. So time period between this four quarters, or time taken to complete this four quarters, is what we call as a time period. I hope this is clear. Now let's suppose someone asks me that my cycle should begin from here. Tell me the time period. So what I'm supposed to do is, I'm again going to develop four quarters. It's a first, it's a second, it's a third, and it's a fourth. Yes, so this will be the time period. I hope this is clear. Yes, if someone asks me that my cycle is going to begin from this, then what I will do, it's a first, second, third, and this is fourth. This is the time period. Let's call this as a T3. I hope this is clear. Now one more thing which is required is what exactly the time period is. If you look at this, if you look at this two situations, that this point and this point, so this is first cycle and this is the next cycle, and both are exactly copy of each other. That means we can say that from this, the previous cycle is begin to repeat. That means time period is when function is going to repeat itself, because as we know, all the simple harmonic motions are the periodic motion itself. So when we say all the simple harmonic motions were periodic motions, it means that it is going to repeat itself, because periodic motion is the one which is going to repeat itself after a fixed interval of time. So this is the time period. I hope you understand. Have you? Have you got this? So are you clear? Are you clear what time period is? Do you understand this? Great. Now let's have a numerical based on it so that it can make concept more clear. If the function is given x equals to 20 sine 40 pi t, find time after which this function will repeat itself. So indirectly they want a time period from us, that is x is equals to 20 sine 40 pi t. This has been given, and my standard formula is, it's an x is equals to a sine omega into t. So from this, it's an omega which is equals to 4040 pi. This is equals to 2 pi by t, which stands to 40 pi. And from this is 2 pi, this is 40 pi, this is 20. So from this, it's a t is equals to 1 by 20 seconds. So not only 1 by 20 seconds, after all 1 by 20, then it's a 2 by 20, then it's a 3 by 20, then it's a 4 by 20, and onwards. That after all this time, After all this time, it's a 1 by 20th of second, this function is going to repeat itself. I hope this is clear. Is it clear? So do you understand what time period is means? Are you serious? Do you understand this? Great. Let's work for the next question. If x is equals to a sine omega t plus a sine 2 omega t, find time period of of above given function. We need to find out the time period of the above given function. How will we do this? So what we understand is that, let's suppose first understand that this is the combination of two function. It's in first it was a sine omega t, and the second function is a sine 2 omega t. So this is basically a summation, or I technically we should say this, that this is the superpositions of two functions. So if I consider this as a single function, then it would be a t1, that is equals to 2 pi by omega. And if this is the second function, then this is 2 omega is equals to 2 pi by t2, and from this it's a t2 which is equals to pi by omega. This is t2, that is equals to pi by omega. So the situation is, this function, it's an a sine 2 omega t, is going to repeat itself by after every time of pi by omega, and this function is going to repeat itself after every 2 pi by omega. So from this I could have this, that this t1 is equals to twice of the t2. Yes, this time period 1 is equals to twice of the time period t2. So if I have more clarity, I could relate this as this function, that let's look at this. This is the circular path, and I am having a two particles. Let's say particle A and particle B. Both are going to start from the same position, and let's say time period of A is the 5 seconds and time period of B is the 10 seconds. That means TB is twice of TA. So if I have been asked we are sticking to this previous numericals only. Yes, just look at this and you will get an idea that what should be the answer. If someone asks me that find out time after which this both the particles will be at the same position after they started the motion. So how will you do this? What I understood is that, let's suppose this A will start its journey and take 5 seconds and will be at here. This B will start its journey and after 10 seconds it will be at here. So when time is the 5 seconds, A will be here, but B will be at here. It has traveled half of the distance because it takes a 10 seconds to complete one revolution. When I assume the situation at time 10 seconds, then particle A would be at here because it has completed two revolutions. Even particle B was here. Yes, because it has completed its first revolution. So again they are on the same position. Yes. So what I can say, it's the time period of this combined motion is 10 seconds. That means after every 10 seconds they would be at the same position. Not only in 10 seconds, if you take a case of 20 seconds, A has completed 4 revolutions, B has completed 2 revolutions. That means they would be at the same position. Let's take a case of 30 seconds. This has completed 6 revolutions. This has completed 3 revolutions. Let's take a case of 40 seconds. This has completed 8 revolutions. They have completed 4 revolutions, and so on. So after multiple of 10 seconds, after every multiple of 10 seconds, they would be at the same position. So now let's understand this. What would be the time period? So what I understand is that, let's suppose this t2 is pi by omega and this was the 5 seconds, let's suppose, understood. Then this must be a 10 second. So they are going to repeat itself by every 10 seconds. So the time period of this function is 2 pi by omega. I hope you got this. Have you got this? Have you? Now, do you have any doubts? Is there anything? Do you have any doubts? No? One more? Let's have a look. That x is equals to a sine omega t plus a sine 2 omega t plus a sine 3 omega t. Find time period of of given function. How shall we do this? We have given this function that x is equals to a sine omega t plus a sine 2 omega t plus a sine 3 omega t, and we need to find out the time period of this given function. So what we understand is, basically this is the combination of three function. First, it's an a sine omega t, or second, it's an a sine 2 omega t, and the third, it's an a sine 3 omega t. So if I want to find out the time period of this function, it's omega is equals to 2 pi by t1, and from this is t1 is equals to 2 pi by omega. This, it's a 2 omega is equals to 2 pi by t2, and from this it's a t2 which is equals to pi by omega. This is 3 omega, so this is equals to 3 omega is equals to 2 pi by t3, and from this it's a t3 which is equals to 2 pi by 3 omega. I hope this is clear. Is it clear? Are you sure? Are you sure? Do you understand this? Yes, correct. So let me modify this as multiplied this and divide this by 3. It's a 6 pi by 3 omega. Multiply and divide by 3. This is 3 pi by 3 omega, and this is at 2 pi by 3 omega already. I hope this is clear. So if I relate this to, if I relate this is t1, this is t2, this is t3, how will we do this? What do you understand from this? What could be done? And when they are going to repeat itself? Yes. What do you understand? How will you do this? That time period of first function, it was 2 pi by omega. Time period of second function, it was pi by omega, and time period of third, it's a 2 pi by 3 omega, or this was it's a 3 pi by 3 omega, and this would be the 6 pi by 3 omega. How will we do this? So again what we understand is that this is the circle, and this is equals to 2 pi by 3 omega. Yes. So what you can do is, let us assume pi by 3 omega is equals to 10 seconds, is equals to 10 basically. Assume it. So if it is pi by 3 omega is 10, then this should be a 60 seconds. If this is pi by 3 omega, that is 10, 10 into 3, this is 30, and this is 20. So now basically we have three particles, first, second and third. One is having a time period of 20 seconds, one is having a time period of 30 seconds, one is having a time period of 60 seconds. So if they started their motion at initial position and from this location and at time t is equals to 0 simultaneously, then at what time they will come back themselves, that means again they all will be at this position itself, because individually they will be at that position at different amount of time, that this particle will be at this position after every 20 seconds, 20, 40, 60, 80 and 100 onwards. This particle, this is the particle number 2, will be at this position after every 30 seconds, 30, 60, 90, 120 and onwards. This particle will be at after every 60 seconds, 60, 120, 180, 240, 300 and onwards. So when they all will be at the same position, when this will occur. So if you observe this, let's take the case of the 60 seconds. What will be the situation? This particle has completed 3 revolutions. This particle has completed 2 revolutions, while this particle has completed 1 revolution, but they would be at the same position when the time of 60 seconds. So it's a time period, it's a time period of this SH, this function, because this is not performing SHM. Time period of this function is 2 pi by omega, because basically this 6 pi by 3 omega has been from 2 pi by omega. I hope this is clear. Is it clear? So do you understand this? I hope you can do this kind of questions. Now let's move to the next category of question. Let's suppose that if a particle performs SHM and started its motion from mean position, then find out time required to complete or find out time required to displace half of the amplitude. It says if a particle performs SHM and started its motion from the mean position, it means this should be the case of A sine omega t. Great. Then find out time required to displace half of the amplitude. That means we need a time when my displacement should be is equals to A by 2. Yes. How will we do this? So this is the basic formula. It's an x is equals to A sine omega t, and what we want a time at which displacement will be A by 2. So if I put x equals to A by 2, this is equals to A by 2 equals to A into sine omega by t. It's omega into t, sorry, it's a 2 pi by t into t. This A and this A has been gone, so this is equals to 1 by 2, which is equals to sine of 2 pi by t into t. So this could be the 2 pi by t into t, that is equals to sine inverse of 1 by 2. This should be, it's a 2 pi by t into t, sine inverse of 1 by 2. It's a sine 30 degree, which is equals to 1 by 2. So it's a 30 degree, or I should say it's a pi by 6. So this pi, this 2 pi, this is 2. So this t would be equals to capital T divided by 12. It's 1/12 of the time period. It takes 1/12 of the time period to reach a by 2 from its mean position, or minus of a by 2 from its mean position. I hope this is clear. Is it clear? Is it? Do you understand this? One more? Great. Let's have a look. The previous question. In the previous question, find out time required. Find out time required to reach at extreme position from mean position. How will you do this? Where do you want to reach? You reach at extreme position. So at extreme position, your displacement will be at A, and you require a time for this. So we have the given the function that it was started its motion from the initial mean position, and that's why we could write this. This is x is equals to a sine omega t, and if it is x equals to a sine omega t, its displacement will be a. So this is equals to a is equals to a sine omega t. This a and a has gone, and this is equals to 1, which is equals to sine omega, which is equals to 2 pi by t into t. From this this is 1. This should be is equals to sine of 2 pi by t into t is equals to 1. From this is 2 pi by t into t. This is equals to sine inverse of 1, and while I say sine inverse of 1, this is equals to 90 degree, which is equals to pi by 2. So this is equals to 2 pi by t into t. So this is pi, and this t could be given as t by 4. This time is the t by 4. I hope this is clear. Is it clear? Is it? Great. So the situation is that if you understand the situation well, this was the situation. This is the mean position. This is x equals to 0. This is x is equals to a by 2. This is the extreme position, x equals to a. This is the x is equals to a by 2 again, and this is x equals to mean position. Again this is equals to x is equals to minus of a by 2. This is x equals to minus of a. This is x equals to minus of a by 2. So when and when my particle travels, it will move in this direction from 0 to a by 2, from a by 2 to a, from a to a by 2, a by 2 to 0, 0 to minus a by 2, minus a by 2 to minus a to minus a by 2, and minus a by 2 to 0. This would be the situation. Now to travel from 0 to a by 2, to travel from 0 to a by 2, you take a time of t by 12, and to travel from 0 to a, you took a time of t by 4. I hope this is clear. So if I calculate this time, that it's a t by 12 plus x is equals to t by 4, you find that this is t by 6. I hope this is clear. So from this time will be a t by 6. This will be a t by 12. This again t by 12. This t by 6. This is t by 6. This is t by 12. I hope this is clear. So this is the complete circle. Basically what we have done is we have divided our motion in 8 segments. Look at this. This is first, second, third, fourth, fifth, sixth, seventh, eighth. So we have divided our motion in the 8th part, and then we have calculated time required to travel each part. So now onwards you don't require a sine or cos. What you need to require is you just remember this diagram, and calculation of time would be very much easier. I hope this is clear. So first I want you guys to copy this and do it quick. That please copy this, and then we will have a question based on this. Did it? Did it? Great. So let's suppose if I have been asked that if particle started its motion, started its motion from mean position, find time to travel 3 by 8th of complete oscillation. Yes. So first thing, what do you want? You want to start your motion from the mean position. Second, you want a time required to travel 3 by 8th of the complete oscillation. So let's understand the situation well. This is the mean position. Yes, as you can see this is the symmetrical diagram. So let's suppose what you need to travel is you need to travel 3 sections of this total 8 segments. So you just take this, it's the first, second and third. Now if someone asks me that sir, I want to move in this direction, it's a first, it's a second and it's a third for me, it is absolutely okay because this is the symmetrical diagram. As you can see this is exactly the mirror symmetry. There is no any difference, there is no any difference in this time taken. So whether you can move in any direction, or if you wish, you can start it from here, it's a first, it's a second and it's a third, even this would be the same. So now what you need to do is the total time required will be equals to, first it's a t by 12 plus it's a t by 6 plus it's a t by 12 again. So this is equals to t by 12 plus t by 12, it's a 2t by 12 plus t by 6, it's a 2t by 12 again. This is equals to 4t by 12 and this is t by 3. This is the time required. This is the time required to complete to complete 3 by 8th of the oscillation. I hope this is clear. One more. Let's begin. Suppose the question is given that if particle started its motion, if particle started its motion from extreme position, then find out time required to complete 5 by 8th of one oscillation. How will you do this? So now in this case you are starting your motion from the extreme position, and when you start your motion from extreme, it should be either from here or it should be either from here. Now what do you want? You want that total 5 segments to be traveled. So 5 segments, it's a first, second, third, fourth and fifth, something like this. Yes. So let's begin then. It was the situation of this time t would be equals to t by 6, it's a first segment, plus t by 12, it's a second segment, plus again t by 12 third segment, plus t by 6 as the fourth segment and t by 6 as the fifth segment. So this is the first, second and third. This should be, it's a 3t by 6. This is the t by 12, this is the t by 12, this is equals to 2t by 12. So this is equals to 3t by 6. When it's a 3t by 6, this is equals to 6t by 12 plus 2t by 12, and this is equals to 8t by 12. This is equals to 4 into 2 divided by 4 into 3t. So this has gone, and this is equals to 2 by 3 of the t. I hope this is clear. Is it clear? So now do you have any doubts in this kind of questions too? Is there anything? Is there? No? Great. Now let's move to the next part. It's a phase of simple harmonic motion. Let's have a look what phase of SHM is. So if I understand phase, it's a physical quantity. Phase is the physical quantity which gives the magnitude and the direction of the displacement of the particle performing SHM at any instant of motion. That is what we call as a phase of an SHM. And the general equation of displacement in SHM is x is equals to a sine omega t plus alpha. In this expression the angle, it's an omega t plus alpha. This angle omega t plus alpha is known as the phase of an SHM. So basically it is the angle what we have written, what we are written in the general relation. That is what we call as the phase of an SHM. Yes. So let's suppose the situation is something like this, that x is equals to a sine omega t plus pi by 4, and I have been asked find out phase of SHM. Then what I need to do is just, it's a copy paste kind of question. It's an x is equals to a sine omega t plus pi by 4. Equate this relation with a standard relation, which is x is equals to a sine omega t plus alpha. This is the phase. So phase of this function phi, we can say, or it's omega t plus pi by 4. If I have been asked initial phase, let's look at this. It's an initial phase. Then at t is equals to 0. So this phi is equals to omega t plus alpha. From this, it's a, let's call it phi naught. It's an initial phase. This is equals to omega naught into 0 plus alpha. So this is equals to alpha. In my case, it's a pi by 4. So this is the initial phase of the given function. I hope this is clear. Is it clear? Is it clear? Are you sure? So basically it represents the displacement of a particular particle at that instant of time. How? Let's have a look. Let's suppose the given function is that x is equals to a sine omega t plus alpha. This is the generalized relation, and my function is x is equals to a sine omega t plus pi. Find displacement of particle at t equals to 0. This is the question. So it means that x is equals to a sine omega into 0. They want at t equals to 0 plus pi. So this is equals to a sine, this is 0 and this is pi. Now what is sine 180? What is sine 180? It's a 0. So if I have started my motion, let's see this according to the circle. If I have started my motion at this position, because this is considered at a mean position. Yes. How do I know that I have started my motion from the mean? Because you are at here. It's an x is equals to a sine omega t. Yes. So if you have started your motion from here, your motion from here, so from this to this you have displaced this, because at this instant this is what we call as a mean position, that you understand, and this is the extreme position. Yes. So you have reached at here if this is the origin. So from this to this and this to this. I hope this is clear. Is it clear? Is it? Now let's take a one more question, and that will make you clear about this. X is equals to, let's say, a sine omega t plus pi by 2, and they will ask me find out displacement of particle at t equals to 0. So in this situation it is x is equals to a sine omega into 0 plus pi by 2, and when I say it's an a sine, it is certain angle plus pi by 2, it's an a sine 90 degree. So when it's an a sine 90 degree, pi is a 180, 180 by 2, sine 90, yes. So this is equals to sine 90 is 1, this is equals to x is equals to a. When I write this, that x is equals to a, that means if I see this, then this is the extreme position and your particle would be at here. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Do you understand this? What we are playing with? Are you sure? Great. Let's take one more question. This seems interesting. Yes? That x is equals to a sine omega t plus 30 degree, that means pi by 6. Find displacement of particle at t equals to 0. You need to find out the displacement. You need to find out the displacement of the particle at t equals to 0. How will you do this? What could be done? So what I understand from this situation is that this is given, which is x is equals to a sine omega t plus pi by 6, and what I want is that I want the displacement of particle at t is equals to 0. So at this t equals to 0, at this t equals to 0, this is equals to x is equals to a sine, this is 0 plus pi by 6, and this should be is equals to a sine pi by 6. It's a 180 by 6, which is a 30 degree, and it's a sine 30. So this is equals to a into sine 30, it's a half a by 2. And when I say it's an a by 2, it is something like this, that this is the circle, this is the 0, and let's say this is the a by 2, and this angle is 30 degree. I hope this is clear. Yes, when it was at this, as we understand from the diagram itself, that this is 90 degree, this complete is a 90 degree, and this would be the 60 degree. Yes, I hope you understand this. So basically if I understand that this is the circle on which I am going to representing the different angles correspondence to their amplitudes. So first I will define one very important term, which is a phase difference. So let's take an example and understood what phase difference is. That let's suppose I have of one function which says x1 is equals to a sine omega t plus alpha, and let's say a different function is there, it says that it's an a sine omega t plus beta. If I want to find out the phase difference, let we call it's a delta phi, then what I need to do is I need to took a phase of this is phi 1, I need to took a phase of this, it's a phi 2, and let's do this, it's a phi 2 minus of phi 1. So as it is a phi 2 minus of phi 1, this is equals to omega t plus beta minus of omega t plus alpha, and this would be equals to omega t would be cancelled out, and this is beta minus alpha, this is the phase difference delta phi. I hope this is clear. So this is the phase difference which is equals to beta minus of alpha. Do you understand this? Have you understood this? Are you sure? Do you have any doubts? So if the situation is given like this, that let's say x1 which is equals to a sine omega t and the second relation, which is x2 is equals to a cos omega t, and they will ask me that find out phase difference between x1 and x2. We need to find out the phase difference between x1 and x2. How will we do this? What can we do? So first thing is that you need to compare this, but as well as you need to look at this, that this is a function of sine while this is a function of cos, and both could not be compared directly. You cannot compare directly sine and cos. So either of them, either sine or cos, you need to convert into the other function. Let's say if both the functions would be of sine, or let's say if both the functions would be of cos. So let me convert this cos. So the situation will be, this is x1 is equals to a sine omega into t, and this is x2 which is equals to a sine omega t plus pi by 2. Yes, this is the first function, this is the second function. Now I could easily find out the phase difference. It is the angle of this, which is equals to omega t plus pi by 2 minus of angle of this, which is equals to omega t. So this will be equals to omega t plus pi by 2 minus of omega t, and this phase difference will be equals to pi by 2. I hope this is clear. Is it clear? Is it? Great. So now let's look at this, that what we are supposed to do is that we have a certain diagram based on the whatever the numericals that we have performed, and from that it is very easy to calculate the phase difference. First let's see this diagram and then we will discuss. This is the circle, and let's say this is the center. This is its mean position that we understand. This is its extreme position that we understand. Mean position, this is extreme position. Please do one thing, please copy this with me so that we can save the time and do the maximum questions. So this is x equals to 0, this is x equals to a, at this again x equals to 0, at this it's an x equals to a. If particle has started its motion from here and a particle has started, a particle has reached to this position, it's an a by 2, this is a by 2, then as we have understand that this is 30 degree. Now there is no question that how this 30, yes, because we have already calculated. This angle would be the 60 degree. This is the again 30 degree, because again this is from x equals to 0 to a by 2 itself, and this angle would be again 60 because it is one of the quadrant. This is a by 2, again this is a by 2. So this would be the 30 degree, this would be the 30 degree, and this is 60 degree, this is 60 degree. If you add this, this is 360 degree. I hope this is clear. Is it clear? Is it? Do you understand this? Do you understand this? So please copy this, please copy this and keep this in your mind. Have you copied it? Did you copy it? Are you sure? Are you sure? Great. Now let's look at the questions, how they will ask this. If two particles started its motion from the mean position, then find out phase difference when one of them is displaced by a by 2 while another is displaced by A. So you want to find out a phase difference between this two when one of them is displaced by A by 2 while other particle is displaced by A. So what I need to do is that according to the data they have given what we understood is that both have started from the mean position. Let's suppose they have started from this, and if they have started from this, one of them has been displaced by A by 2, one particle is here, while another has been displaced by A, this is here. Sorry. So what I want the phase difference. It's an angle difference between these two, and it is very easy that from the diagram it is the delta phi. It is equals to phi. This is, let's say this is this is second particle, this is first particle. Angle of second particle from this is 90 degree, and angle of this from the first particle, it's a 30 degree. So there is a phase difference of 60 degree, or I should say it's a pi by 3 radian between these two. I hope this is clear, and that's it. You did it. Great job. I hope this is clear. Is it clear? Is it? Do you understand this? Have you got this? Done? Great. Ready for one more question? Let's have a look. That if two particles started their motion from mean position, both of them meet at half of the amplitude while both are moving in opposite direction. Find out phase difference between these two. How will we do this? They said that there are two particles, and that two particles have started their motion from its mean position, and both of them meet or they cross each other at half of the amplitude. But when they meet or when they cross each other, they both were moving in the opposite direction, and you need to find out the phase difference between these two. How this is possible? So if you understand this diagrammatically, this is mean, this is A by 2, this is A, this is again A by 2, and this is mean. So this is the situation. Let's say this is x equals to 0, this is x equals to A by 2, this is x equals to A, again A by 2, and again 0. So they meet at A by 2. Let's say first particle is moving in this direction. That means he has started his motion from 0, and he has traveled this much from 0 to A by 2, and it is moving in this direction. While other is moving, they are crossing at A by 2, but other is moving in this direction. But even this has started its motion from the mean position. Sorry. So it means even it has started its motion from here. He has traveled from 0 to A, and then it is at A by 2. So according to the situation, if you observe this circle, your one particle will be at this. It says at A by 2. Other particle is this. It's A by 2. This is 30 degree. Even this is 30. So that means this is 60 degree. So if I call this as a first particle and this as a second particle, so the phase of second particle, this is 90 plus 60. It's a 90 plus 60, which is equals to 150 degree. and the phase of the second particle, which is equals to 30 degree. So the phase difference delta phi, which is equals to phi 2 minus phi 1, this is equals to 150 degree minus of 30 degree, and this is equals to 120 degree. I hope this is clear. Is it clear? Do you understand this? This is the phase difference between these two particles. I hope this is clear. Is it? Is it? So now do you understand what phase difference is and how should we deal with it? Do you understand it? Are you sure? Do you have any doubts up till now? Do you? Do you have any doubts? No? Great. So let's wind up this session over here. This was all about the time period and phase difference of SHM waves. Please revise this very carefully because this concept, this same concept we are going to use in the waves as well. It was the next unit to this. So a same concept, a same phases, same phase diagram would be required in waves too. Please do this very carefully, and that will help us to get the numericals done. Thank you. Have a good day. Take care. Bye bye.